Alright, in this video I would like to take a look at the shape of a distribution, the shape of distributions, and the way we're going to visualize the distribution, we're going to start with a histogram and kind of translate from a histogram into a continuous curve, and that'll get us set up to do some future discussions, have future conversations about the shape of distributions if they're given with a nice smooth curve. Okay, so for this one, let's start out with an example. I'm going to pull material from chapter 2 and chapter 3. So, we're going to make a histogram and talk about frequency distributions and things from chapter 2, and we're also going to use that to facilitate our conversation in chapter 3 and describe the center of measure and mean, median, and mode, and use those to describe the symmetry and to describe the skewness of a graph, okay, of a distribution. So let's start out with our example. Let's say that I roll one die 50 times, okay, and I record just the face value. Okay, that'll be our x. Okay, so here's our distribution. I'm going to draw it with a vertical table matching the one in the book, the style of the book. Here we go. Here's our x and then our frequency f. And so what values could x take on? Well, if I'm talking about rolling one die, then the values that x could be 1, 2, 3, 4, 5, and 6. Okay. Now let's suppose that I rolled, out of those 50 times, I rolled a value 1 3 times, a value 2 4 times, a value 3 5 times. Can you see where the data comes from? I rolled a value 4 11 times, value 5 12 times, a value 6 15 times. Okay, so this is a nice frequency distribution for the variable of face value of the one die. If you added up each one of these values for f, you would notice that they added up to 50, and that's good. So the sum of the f's has to equal the sample size. And again, this is a sample mainly because it's better to always default to sample. So in other words, our value for lowercase n is 50. But also this is 50 times rolling a die out of an infinite number of die rolls. So it's always going to be a sample if you can always generate more data. Okay. Alright, so the things that we want to describe and explore for this data set or this distribution, we want to look at the mean of this data set, we want to look at the median, we want to look at the mode. Alright, we want to create a histogram to visualize it, and we also want to explore the idea of relative frequencies. Okay, so relative frequencies. Alright, and we want to use that as a basis to kind of explore the shape of a graph if we transform the data. Okay, and that's kind of a conversation starter for a later time. And off the top of my head I can't remember the chapter, but really we just want to get our heads around the idea of what a graph should look like and how the distribution should be shaped, and it doesn't really matter on there's certain things that we could change that won't influence the shape. Okay, so the very first thing we want to look at is the total values here. So what we've done with the frequency distribution is I haven't, in past examples we've listed out each value for x. So in other words, on and so forth, we have this is saying we have 3 copies of 1, 4 copies of 2, on and so forth. So I don't want to list out each one of those. I don't want to have 50 numbers listed out. And so what we have really is a nice shorthand form, but notice that if I were to add these up, right, so to find the mean we need to add them up, add each value in the x distribution, but notice that we don't have to here, and what we can do is we can actually just take the product of f and x. So let's look at that. Product of f and x, f times x, so 1 times 3. If I added up the 3 ones, I have 3. If I added up the 4 2s, I would have 8, 15, 44, 5 and 20 is 60, 6 and 15 is 90. Okay, so there's a couple things that I want to look at with this. One is the idea of the mean. So we can find the sample mean which maybe I'll clear this up a bit, we can find the sample mean by multiplying and finding this product here, and then adding up each one of these. So this would give us a total value of our distribution, and then we're going to divide that by the sample space. So the formula for finding the mean, so the sample mean is equal to either the sum of the x's directly divided by n, or the sum of the frequencies times the x then divided by n. Okay, so that's what we have here, and so we have 3 plus 8 plus 15 plus 44 plus 60 plus 90. All of that will be divided by 50. So that's the sample size. So let's see, I should have added these up ahead of time, I know. So 90 and 60 is 150, 165, 169, 209, 212, 220. So this is 220 over 50, and we do some fun math and we find that our sample mean is 4.2/5. Let's see, 4.4. Okay, so the value of our mean is 4.4. So what is this saying? This is saying that since we have a lot of data down here, the central line for this, instead of being split evenly on the x's, it's split in the sense of finding the values heavier weighted items, drag the mean towards them. So we find that 4.4, our mean is, in this area. Okay, because the bulk of the data is down here. All right, now if we were looking at the mode, I'll do this in yellow. The mode is just the most frequent. So the most frequent observation, well, we have 15 copies of 6, so the mode is 6. That doesn't seem very descriptive. Now what about the median? Okay, so the median is going to take a little bit of work. Remember that the median is I'll do this in red, the n plus 1 over 2, that observation. So because we have 50 entries, we're going to take 50, add 1, so 51, and divide that by 2, so it's 25.5. So we're going to take the average between the 25 and the 26th observation. Okay, and we could find that by counting up. So 25, we're going to count 3, 7, 12, 23. So we have 24, 25, 26. So 25, the 25th and the 26th observation are both 5. So our median will be 5. Okay, so here we have our descriptions of the center. We have the mode, which is 6, seems unlikely. We have the median, which is 5. That seems a little bit better. It's kind of the middle number for the observations. I have a video on that one, on the difference between median and mean. And then our mean is 4.4. All right, so let's see here. Let's look at the shape of the graph. So one of the things that we want to do before I switch pages here, let's look at the relative frequency. So in other words, what proportion of the time does the value 1 occur in this distribution? Okay, so notice it pops up 3 times. In other words, 3 times out of 50. So what I want to do is make a column for the relative frequencies. So this would be 3 out of 50, which is 0.06. The value 2 occurs 4 out of 50, which is 0.08. So 8% of the time we saw a value of 2. Value 3 pops up 5 out of 50, which is 10% of the time. Value 4 is 22% of the time. The value 5 is 24% of the time, and the value 6 occurs 30% of the time. Okay, so here's our distribution on a new sheet. I made it a little bit smaller so we have more room to work. Let's see here. Let's put in our mean, which was 4.4. Our median was 5. Our mode was 6. Okay, so remember that the mean is the center of the weighted values. So it's giving us, based on the values themselves, so 1, 2, 3, 4, 5, 6 as weights, the mean represents the center according to the frequency of those weights. So the more times a heavier object appears, it's going to cause the mean to drag towards it. The median is the center of the observations in terms of their order. So we took the middle 2 observations, the 25th and the 26th value, and averaged them and got 5. And then the mode is the most frequent observed value. So we have 15 occurrences of the value 6. Alright, so I have two clean sets of axes here, and I want to graph it frequency distribution. So I want to graph a histogram based on the frequency here. So we saw the value 1 3 times. We saw the value 2 4 times. We saw the value 3 5 times. Okay, again, notice that I'm centering or trying to center each rectangle on the value that we're talking about. So the height of the rectangle tells you the frequency. So that's what's going on over here. Frequency over here, we have the x. Alright, so the value 4, we saw a spike all the way up to 11. So 11. Value 5 was up at 12, so a little bit higher, 12. And the value 6 was all the way up here at 15. Okay, great. So when you look at this nice graph here, if you see a taller bar, well, that means there's more of that value. Okay, so this is the frequency. If we look at the graph based on the relative proportion, then we would see that, okay, so remember this 0.06 was really 3 out of 50. This was actually 4 out of 50. This was 5 out of 50, 11 out of 50, 24 out of 50, not 24, excuse me, 12 out of 50, and then 15 out of 50. And so if we were to graph these on this set down here, so I'm going to graph f over n and then x. So these numbers, I forgot to put this here. This is really out of 50, out of 50, out of 50. Okay? And now you know my secret. Okay, so we have 1, which is 3 out of 50, 4 out of 50 for 2, 5 out of 50 for 3, and notice we're just graphing the same thing. It doesn't quite look the same, but it is. 4 skyrocketed up to 11 out of 50. Okay, 5 was 12 out of 50. And then 6 was all the way up here, 15 out of 50. Alright, so when you look at this, they're the same exact graph in terms of shape, but the scale of the vertical axis is different. So the vertical axis is different. We have a big point to make here. That is, if we change the scale of either one of the axes, so x or y, it won't change the overall shape. I mean, it might look slightly different. This is actually a little bit squattier, but it's just a scaled version of the graph up here. I think it's purple. I'm going with purple now. Okay, so the green graph is the same as the purple graph, even though the scale on the vertical axis is different. Okay, let's use just this purple one, and let's put in the values for our mean, median, and mode. Okay, so I'm going to use, let's see, red, and I'm going to say just a vertical line to represent 4.4. So it's in here. This is 4.4. This is our mean. Okay, and this white, I'm going to put the median, which is up here at 5. So that's our median, 5. And then in this green, I'm going to put the mode in at 6. Put the mode in at 6. Accidentally erased my page. Mode equals 6. Alright, so one of the things that we want to point out, maybe I'll put this in a little bit more solid colors. For this mean to be less than the median, we would say that this distribution is skewed. Okay, if the mean equals the median, we say that the distribution is symmetric. Okay, with this, since it is skewed, we need to classify. This is getting at the shape of the graph. We need to classify the skew factor, or the direction of the skew. So based on this, you notice that the tail. So the shorter the values, that's the tail. It's on the left, so we'd say that this is skewed left. So if the graph looked different, so something like this, you had your values descending like so, we would say, because here your shorter bars are on the right hand side of the graph, we'd say that this is skewed right. So this is, or sometimes we call it right skew. and this would be left skew. Okay. Another way we look at this is by looking at the positioning of the mean and the median. And so if the mean is on the left of the median, we'd say it's left skewed. If it's on the right of the median, we'd say it's right skewed. Again, the larger values drag the mean towards it. And so if you have a data set with lots of big values, they're going to be more susceptible to, by big values, I don't mean tall bars, I mean big values down here. The mean is going to be dragged towards those values. So up here, even if this was 6, the mean is still going to be pulled up towards the larger values, whereas the median is going to follow the heights of the bars. Okay? If something is skewed, it's not symmetric. If it were symmetric, then you would have the mean and median matching up. A picture of something that is symmetric might look like this, where you have this kind of evenness to it. Mine's not quite symmetric, but you get the idea where it's more well, yeah, evenly distributed like we would expect. You also have this idea of the mode to consider. So this graph right here, we would say that it is unimodal because there's only one distinguishable mode. Up here with this graph, it's also unimodal because there's one clearly distinguishable mode. If I look at a different graph, and I'm just going to quickly sketch these. So let's thin up this line a bit. Here's my quick sketch. If I had a sketch that had something like so, some space, so there's one mode, there's the highest point, so whatever value you have down here, let's say 2, and then we had some gap like so. We have this second mode. Maybe this is the value 5. And so looking at these two and the frequency up here, it doesn't have to match, but let's say that it does at the value 10. This is what we call bimodal. So bimodal, meaning it has, whoops, it's a bimodal. Bimodal. Okay, so it has two modes, and if it's unimodal, it has one mode. If it's bimodal, it has two modes. After that, I think it's just maybe multimodal. But the idea here is you might still have a symmetric graph. This is fairly symmetric, right? If we drew symmetry, meaning we could draw a center line. So let's see that. I might put in the center line right here. And if I look at this graph and I reflected about this center line, it would probably land pretty much on this. So in other words, they're reflections or mirror images of each other. So this is probably still maybe symmetric. Symmetry is good. Yes, good. But it's not, so it's not perfectly symmetric, but it's probably pretty darn close, but it's still bimodal. And again, we're going to be measuring symmetry whether or not the mean equals the median. Okay, so because there's even distribution within each grouping, it's probably got this nice symmetry. Okay. One of the things, though, that's nice if we have a lot of values. So I had 50 for our example. If we roll the die 50 times, if we have a lot of values, and as that 50 increases, maybe goes to 100, 1,000, on and so forth, we're going to get to a place where we don't have to graph each bar of the histogram. We can actually use an approximation. So something like a smooth curve to approximate. So the graph in red would be the nice approximation to the histogram. And why it's so nice? Well, if it's a smooth curve, we can put an equation to it. So there's an equation that represents that smooth curve. Some, maybe it's not a nice equation, but it's still an equation. And if so, then we can do computations much, much easier. And so we're going to be focusing on nice unimodal graphs that have symmetry. So a shape something like this, a nice sequential stepping up, and then we step down. I don't know if that's enough. Something like that, where it's unimodal, it's symmetric, and if we drew that continuous curve, you get something like this. That shape is called the bell curve. Okay, also known as the normal distribution. Okay, so we will talk about that in chapter 5, I think. we have to discuss measures of spread, which we'll get to in Chapter 4. But the idea is that we want to simplify and approximate these histograms with a continuous smooth curve, and these continuous curves are really nice for calculations because they have equations.